Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We are working on this bat AI, right? So placeholder bat art for now. We have them chasing us, which is good. It's just that once they kind of cross paths with one another, they can kind of get stuck. And we've got them really slow, like this. Look at that. So see how they're like stuck inside each other right there? It just is too... See, look, they're like perfectly synced, which we want to avoid. So I'm kind of thinking I want to fix this by tweaking some stuff. So right here we have... Basically, depending on the position that the bat is in relation to the player, we're doing a certain sort of something, which is just moving us directly towards the player if it's orthogonal, either up, down, left, or right. Then if it's diagonal, we go both towards we go diagonally towards the player. So if we're up left of the bat, we're going to go down and to the right. Or up and to the left because the player is up and to the left of us. So I think the way we can tweak this a bit is like, I did change the speed of the bats so they don't go the exact same speed, so that's why they're not like perfectly synced up the whole time with one another, but I'm kind of thinking I want to just kind of offset their trajectory just a little bit. So I'm not exactly sure what we should do about that. But I'm thinking that if we have, I guess we'd call it like an offset or a wiggle, an X wiggle or something, that instead of moving directly up towards us, it would kind of move in a zigzag, right? And then if it's moving left, we'd give it a zigzag like this. So maybe we can do this sort of displacement based on the direction as well. The only issue is, you know what? Let's just try to play around with it, and we'll see if we can get anything we like just messing around with it. So I think the move is we'll go to our bat entity, and we'll give it an X wiggle and a Y wiggle. Or whatever we want to call that, displacement. We could call it displacement. So I think, let's see if we can go into our map declarations. And when we give ourselves the bat entity, what if we were to give it a... we can give it like a displacement option. So let's try this for one of the bats. I'm curious, like if we just put a variable in there, is it okay? Like it doesn't crash or anything? Okay, so we have this displacement option for this entity. So when our bat is in its walk state, let's say that this displacement option is part of the entity. So it'd be self.entity.displacement option. So we can say that there is going to be a displacement X and a displacement Y. And if our... See, and should this be a displacement for the entity? Probably not the state. So let's say that we give our entity the displacement X and Y. Initialize it to 0, and then we'll have this... I guess we'll call it like displacement threshold or magnitude. So we'll say for right now, let's just try a magnitude of 5. So, okay, so we have to ask if the entity displacement option that we gave it, which we gave it a 1, right? Because we want to be able to have different displacements for each one so that they're not the same, so that they don't just overlap with one another. So displacement option for the entity, if that is equal to 1, then we want to set this displacement magnitude equal to something like 5. Now what 5 would be like 5 pixels worth of displacement. So each tile is 15 or 16 pixels wide and high. So a displacement magnitude of 5 would give us both a positive 5 and a negative 5 displacement. So that's a total of 10 pixels. So just shy of a whole sprite size of displacement. Maybe we'll give it 8 just to see what a whole sprite of displacement would look like. So the idea is we have different magnitudes. Magnitude would be like how fast is it wiggling, or how far is it wiggling in this displacement. And then we have to have like a sort of, and I'm curious, like, can we just keep adding fields to the entity? We can't. So 20, we crash at 20, so it doesn't like this. Well, I spelled this wrong, so maybe we can. I think we could just say that there's a field called displacement X, and it just works like that. So now what we want to do is we want to print up what this displacement X and Y is. So we'll just worry about X for now. And if this is our bat walk state, we can print up the displacement X. So let's just say that this is displacement X. Okay. So now we should be printing 0 up above our bat, and that'll be our displacement X, which right now we're not doing anything. So displacement X is going to be how far wiggling displacement on the x-axis each bat gets, and hopefully we can give them different displacements. And it should just vary their trajectory so they're not moving perfectly diagonal towards us, which they are right now. So we gave ourselves this displacement X and Y. Now we also need like a I want to say it's like we need a flag to, because the idea is we want this value to go from 0 to the magnitude. So 0 to displacement magnitude of 8, back down to 0, back down to -8, back up. Now I guess we could just keep it positive. Let's do that. Let's just keep it positive. So it'll go from 0 up to 8. When it hits 8, it'll go back down to 0. So no. We need it to go negative because we want it to wiggle. Yeah, we don't want it to just wiggle to the right and back. We want it to wiggle past. Yeah, because if we're moving directly diagonal, ideally we want it to be kind of zigzag diagonal. We don't want it to be like, I don't know. I feel like we want it negative. Maybe we try it positive and see if I'm just imagining stuff in my head. But we're going to say that the entity gets a displace positive. That's a bad name for it, but basically, like I want a flag to count, hey, we're at 0 going up, so keep incrementing the displacement till we hit the magnitude, then swap the flag to decreasing. So displace increase or decrease. if we're just worrying about positive numbers. Let's try that. Increase. So we'll since we initialized to 0, we'll displace increase to true. So it'll go from 0 up to the displacement magnitude, and then back down to 0, and then back up. So let's see if we can get this working on just the displace x. So in our update, we can say, okay, well, if our displaces increase, then we want to adjust our displace x, and it's going to be entity displace increase and entity displacement x. We're going to say that that value is going to be updated by a certain amount of, we can just do delta time for now. So we can say if we're increase, then go ahead and just up our displacement x by delta time. And then once we get to the magnitude, then we can reset the flag down to displace decrease, and then work our way back down to 0. So we can hopefully get this kind of sinusoidal wiggle. So we can say if the self.entity displacement x is greater than or equal to the magnitude that we're trying to displace, then we want to become displace decrease, essentially. So displace increase gets false, and then we can say if we're decreasing, if our entity displace increase not, so if we're decreasing, then let's take our displacement x and decrease it by delta time instead of increase. And then the same thing, if our displacement x is smaller than or equal to 0, then we need to go back upwards. Then we're going to become entity displace increase true. Okay, so we should, since our magnitude is initialized here to 8, I'm hoping to see this displace x go from 0 to 8 back down to 0, and then just keep going from 0 to 8. Now we're not changing our bat position just yet, but we're looking for that. Shoot. Bat walk state 40. Displacement x. Entity displacement magnitude, entity displacement magnitude. Let's see, I'm curious if we can just say 8 here, if it still crashes. No. Okay, so it goes, delta time is too slow, but we can, it should go to 8 and then back down. Yeah, I didn't see it touch. And then once it hits 0, it should go back up to 8. Okay, that's looking right. Just too slow, right? But why can we not, let's say, instead of the option, let's give the magnitude here. So let's say that we just define in our map declarations not a displace option, but the magnitude here. And for now we'll put, let's just put up to 5 just because it'll be faster, and then we'll put, instead of delta time, we'll do delta time times 2. Okay, so we should go up to 5, down to 0. Okay. Oh, did we not change the hard-coded 8 in the update? Yeah. So we need to say entity displace magnitude. Okay, which should be 5. Shit. Displacement magnitude. Displacement magnitude. Okay, we might have to do... Let's look at our entity class real quick and see if we have to copy over the fields. Yeah, I think we do. So let's do this where we say, okay, well, our displacement magnitude is pulled from our defined displacement magnitude. Okay. If we crash here, I don't know what's up. Cool. Should hit 5 and go back down to 0. Cool. Oh, we didn't give our other bat a displacement magnitude. What we could do is in the entity here, we could say or nil if there's not one defined. And then I think it would solve that crash. Maybe not, because we're doing arithmetic on it. So let's just say we have to have a displacement magnitude for a bat entity, so we'll just go to where we're doing our bats and give a displacement magnitude to both bats. Cool. Okay. So that's looking okay. I feel like we want to speed up the displacement magnitude maybe to ×3 delta time. And then we want to actually change our bat's position based on this displacement x. So we can't just add the displacement every frame, because then we'll go yeah, we can't just add it. Let's see what happens if we just add it to every scenario here. Like here, if we say anytime we add walk speed, we also want to add the displacement x. That's going to get too far though. Because like, let's say displacement x is at 5, we're going to add 5 pixels to our x position. And then the very next frame, we're going to add 5 pixels. So it's going to get crazy fast. It's going to go off screen too fast. So it's almost like we just need to do whatever we do. Ah, man. Because, yeah, we can't just add... Man, I should have thought this better through. Because the value we're getting from the displacement x, you know, a value from negative or from 0 to positive 5, we want that to be the, like we're saying, the displacement, not the... We don't update it every frame and add the displacement. We just displace our original position. I don't know how to do this. It'll get too jacked up. Like let's just say like we do our movement, and then once we're done with our movement, let's just take our entity's x position and modify it by the displacement, right? So just say, like we say, our x position, yeah, it's going to get too far back. Displacement x plus our original entity x. Okay, so the x, it should teleport, basically. It should be like so fast, right? Yeah. So how do we... Like, we just want to move... I guess what we can do is... No, I don't know how this works. Because the idea is, like, if it's moving in a diagonal, whatever this displacement x is going to be is, like... It should be 5 pixels, or, you know, if it goes from 0 to 5... 5 pixels positive would be 5 pixels to the right. So it should go from 0 is 0 displaced, 1 pixel is 1 pixel displaced, 5 is 5 pixels displaced. But then the next frame, we're still that 5 pixels displaced. But our x position doesn't get added the whole displacement. We just need to... Man, why is it hard for me to think this through? Because we don't want to do what we're doing here, which is adding the displacement x every frame. But maybe what we need to do is displace us by the right pixel, then undisplace us, so the next... Yeah, I think that's what you have to do. I think what we have to do is we can say our x gets this displacement x, but then once we render our bat, I think we need to undisplace us, so that we can redisplace this again. So we say, okay, well now our x is going to become what we used to be, but minus this displacement x, so that we can continue to add that variable. So let's try that. We shouldn't fly off to the right this time. Shit. Self.entity x. Hi there, Emma. I am using Love2d with the Lua programming language. I'm going to take out one of our bats so that I can see better. We do want the negative because once we hit the displacement x of 0, it like stops moving. Well, see... See, it like slows down. I do kind of like this though. Well, because I want his speed to be the same. I just want his path to be displaced. But I guess if he's moving on the x-axis, then we can't have his speed be the same because we're displacing him. So let's see if he's tracking, when he's tracking us downwards, see how he wiggles from center to the right, back to center. Yeah. I think we do want the negative value. Well, yeah, Emma, you should continue to try. I like this engine. I'm sticking with it because I first learned on this engine, so I'm trying to build something fairly complex with this engine. But if you look up on YouTube, CS50 Game Dev, they walk you through how to use this engine, and they build Pong first, and then Flappy Bird, and then I think like a Tetris match game or something after that, and then a Zelda game, which is a dungeon game, a lot like this, where we can just walk in the overworld and have enemies and stuff. So if you're interested in it and you've fallen off the horse in the past, I say if you follow the YouTube videos, you can definitely kind of use those videos to kind of keep you chugging along. I don't know what your is. Oh, Unreal Engine? Or I don't know. Yeah, I think we want... See, I like the wiggle. I think the wiggle speed is fine, but I think we do need from positive to negative. But I do like the speed. I think the speed is fine. So let's go... Yeah, Unreal Engine is too much for me right now. I'm trying to stay 2D first. I feel like there's so much to learn. I want to kind of... Yo, what up, Brightside? How's it going, dude? Yeah, I'm a little intimidated by 3D for sure. Nice, man. Yeah, well, we just added bats. So we've got this, like, the artwork is still temporary, but we just got something in there. So they wait a little while and then they track us. And this number that's on there is tweaking its X position as it tracks us. So it's not in a straight line, but he's like wiggling back and forth while he tracks us. And then right now he stops like just outside our range, because that's where once he stops like right there, that's when he's going to switch to his attack state and spit acid at us or whatever. And then we can use our spell casting to kind of hit him and knock him back. So we're trying to get this displacement for its X position working okay. Oh, see, and this is weird. Like, see the numbers, like the decimal for the numbers is moving left and right, but the bat itself isn't. So that's kind of interesting. What is FNAF? No. I'm not sure what that is. But yeah, we're on the road to having a demo, Brightside. So like I really appreciated you showing the Steam stuff yesterday, where you're doing. Oh, gotcha. I've never played, but I know it's popular and stuff. Yeah, we're trying to get a demo done so that we can hopefully get it on Steam for wishlist. So we're trying to finish the first dungeon, and bats are the enemy in the dungeon. So we have gecko entities and bat entities right now, and we do have like treasure chest and pushing stuff, so we can like open this treasure chest and get some. Wow, the bat just got all crazy. We've got these these crates also that you can push. So we can have like little like Sokoban style pushing puzzles and stuff. And then the crates are also breakable to get some like coins inside and stuff. So we're hoping to get this demo done so we can kind of list it up on Steam and be able to share with people a link to this. I'm not sure how it works. Like if it's on for wish listing, can you add a executable build for the demo or something on Steam there? Because if that's the case, it can make it easier for people to play or to download and play the demo, which is one of the big goals, is just to have super easy for people to try to play the game and everything. So that's why I'm focusing on the web deployment and this demo for Steam listing. But I'm hoping it'll be done in like the next month, but I think that's too ambitious. But we're gonna say a month and keep going. Thanks, man. Yeah, it's dude, game dev is ridiculous tough, because it's like I feel like we just got to the point where we can start about actually building a demo, and we're coming up on a year of development, which is nuts. Yeah, I heard it does cost $100, but luckily the revenue from Twitch can cover my $100, so I've already committed to paying that out of the Twitch revenue I've gotten. So like that's super cool. So I'm considering it free because the community help pay for it. So I'm excited about that. I just don't know all the work it takes, but that's part of the process. 3 available branches: main, beta, and demo. Okay. Nice. Yeah, I'm excited to figure that part out. My game is always going to be free for people to download, just because I want people to be able to play it, so I don't want any barrier to entry. But a Steam page can help people find it, and other people who wouldn't necessarily find it and be able to play it from that way. So I think that's really cool. Okay, so we want this displacement X to not just be 0 to the magnitude and back down to 0. We want it to go to negative, right? So once we become decreasing, then we're going to subtract the displacement, and then once we get to the negative displacement, that's when we want to flip back to positive. And then we increase. Okay, so let's check out the wiggle on the X. Yeah, exactly. Itch is a good one I want to get to also. Why is the displacement X not working? Negative displacement magnitude. Yeah, so see how he's kind of wiggling left and right as he flies towards us? I think it should be faster. Oh, but see, look, why? Oh, he stops. Oh, we stop updating the bat's position once he gets close enough, but the displacement X is still being updated, so that's why the decimal's moving, but the bat is not. Oh, he can sneak up on us. Okay. I think we need to, yeah, maybe like multiply this by 5 so he wiggles faster. And then we need to displace Y as well as X. Yeah, see, when he's moving diagonally, see, look, that is just weird. I do like that it's not as as a straight line as it used to be. But then again, you know what? It's, you know, it's, I've got to turn that off, the numbers off, because I can't see what I'm looking at. If we just wait to the left, what does the displaced X look like? See, it looks like he's going the same exact speed. It looks like he just goes the same exact speed. There we can see him wiggle from right to the left, so that's good. So maybe once we add the displaced Y, it'll look okay. But I mean, I like that he wiggles like that. That looks a lot better, I think. And he's still tracking us, and he's still stopping when he gets a certain distance close to us. Oh, that was jacked up. Wow, we might be screwing this part up. I want to render this hitbox. No, not this one. We have... I just want to make sure that the bat we're rendering... Well, we're rendering the bat at our own X and Y position, so that is indicative of where the bat literally is. I just don't get why he kind of teleported through us instead of stopping, right? Oh, man, that's a little close. That's a little too close. It has to be... Oh my gosh, see, that's so close. He normally doesn't get that close. So it might be here, like we're saying, if the distance to player... Where do we calculate the distance to player? Right here. At the beginning. Okay, so why don't we... Yeah, I guess it makes sense, because we calculate the distance first, and then we only update its position if... Now, I think we need to add the displacement value here somewhere. Or we have to calculate considering the displacement value, because if we're only... Yeah, it's got to be the displacement value, because what's screwed up here is that we might be only 25 pixels away from our player, but if our displacement is really high and it's like 5, then thanks, Brightside. Yeah, I appreciate that. Yeah, I'm not too worried about all the graphical assets. I think that'll be a fun little stream day to kind of knock out, especially because my stuff is pixel art, right? So it's not like I gotta do super high def renders or anything. So I think it'll be pretty easy. I'm worried about like the opening dialogue and cinematic, getting the opening cinematic looking nice, and then that controller support is big. I don't know if that's required for the demo or not, but I do want to make sure we play nice with the controller support so that we have a good chance of getting approved to be on Steam. But yeah, itch is a good idea, Emma. Thank you for that. I think I do want to do that. But yeah, if our displacement is like, let's say 5, a full 5, and it's a full 5 negative on the X, then our bat's only 25 away from us, but our displacement is putting us 5 pixels closer. And we kind of displace ourselves, render ourselves, and then move our entity back. So I think, yeah, how would we... Yeah, we just have to add our displacement to this get distance to player. We have to account for this displacement. So when we go to calculate the length for our Pythagorean we need to account for the displacement x. So if we take the absolute value of our player x and our entity x, would we put the difference? Gosh, it's hard to think about this. Okay, so A length is our, like, the bottom, the x axis of our triangle, and we're taking the player x, subtracting the entity x, doing the absolute value. So the distance here, we take the absolute value of there, and then I think we have to then add the displacement after the absolute value, because we could have a negative displacement or a positive, and both of those change the distance of this A length. So I think we can do this displacement x here. I could be wrong on that, but let's see. He shouldn't get that close to us. He should be just out of reach of our, or just in reach of our spellcasting. Oh, yeah, that looks about right. Let's just make sure he can't get too close. Oh, that's way too close, dude. That's way too close. Bro. Yeah, see, like, if we were to print up, like, the distance to player there, that was really close. I don't know. It's hard for my brain to think about what the equation is here. I'm going to just put a minus sign there just to see what happens. That's way too close, man. That's way too freaking close. Yeah. This should be right, though. This should be, because we're taking the absolute value of the difference of our player to our entity, but then the length, we have to also account for this displacement. If it's positive, then the length is further. Yeah, so we'd add it. And if it's negative, we add the negative, which shrinks our A length. So it should be this plus sign. But he got way too close when we did that. Oh, Jesus, dude. Yeah, that's too close. See, it looks fine on the y-axis, but here, well, that looks fine too. It's just diagonally he gets way too close. Maybe we just continue on with the y displace and see if that helps us. Oh my god. Well, technically, oh my god, why did he sneak up on us like that? Why is he creeping up on us? Why did he all of a sudden get... Oh my god, this is freaking me out. He like snuck up on us right when we cast a spell. Wow, he really just don't care. Okay, what I'm going to do is try the displacement y and then maybe increase the distance between him stopping, and we'll tweak it from there. So I guess we want to also do our displacement y the same way here. And then This is okay. I think this is okay. If we have the same displacement, then the flag, the Boolean flag, can also be the same. And then we need a minus here. Okay. And then when we go to render, we can render where do we do this? We're basically modifying our X position by the displacement, and then we render, and then we undisplace so that we can re-add it again. So we need to, this should be entity Y and entity Y, and then this. And then, okay, let's see. Hey Nemesis, what's up? Welcome in. We're getting the AI on our bats tweaked a little bit. I like it a lot better now that he kind of wiggles towards us. So he is tracking us. Oh my gosh, it's just that bottom corner that he gets too close to us. Cause that, oh, why does he creep up? He like sneaks up and inches in. We also need to set our displacement. Oh my god. We need to set our displacement as soon as we stop. We have, if we're close enough to the player, we need to reset both displacement values so that we don't accidentally initialize a movement again with a high displacement value, making it look like we jump. So we do have to we can reset our displacement positions, and then also probably do our, is it displace increase? True. So kind of reset our displacement values so we don't go crazy. Let's see. Oh, he looks janky. He looks really janky. That should not be happening. Okay. I don't think that was the right move. Why does he get so close? Hey, thank you for the follow. Appreciate it. Yeah, Gullible. Yeah, thank you. Thank you for the follow. I appreciate it. Yeah, I am. I'm definitely. I mean, I'm not new to programming, but I just program as a hobby, and I've been teaching myself for 4 years now. So I don't know what I'm doing, but I'm figuring it out. So I'm excited that this new stuff seems to be coming along. I thought we'd be done with this feature already, but it's not coming together like I thought it would. I think I want to play Nemesis. I'll do only game dev, only Lua for game dev. But I do program a little bit of Python and C and a little bit of Go, JavaScript, that sort of stuff. Thanks, Gullible. Yeah, the it's modeled after Link's Awakening. We made our own sprites for it, but a lot of it is mimicked off of Link's Awakening, so that's kind of where the inspiration's coming from. I think I want to print up the distance to player because for whatever reason, when we're in the bottom left or bottom right of the bat, he seems to get really close. Like that. Like he shouldn't be that close. And then he like glitches out and hits us. That is so weird. So let's print up the distance to player here. D flat, nice. I've heard of C sharp, and D flat is essentially C sharp, so makes a lot of sense to me. Oh, see, why is he 20? Oh, see, it's the displacement. Yo, this is so weird. So we don't, like, you could see the number getting really close to us, and the number is being rendered at the, is it, oh, and that's why we're colliding. No, oh. Shoot. Why is the number still being rendered with the displacement? We're rendering it at... Oh, we're doing this... Okay. We'll render the... Yeah, we'll render that before we undisplace ourselves. So it should be stuck to the bat now. Okay, that's looking better. I do like that he zigzags. Okay, but see, look, why does he inch towards us? We shouldn't be changing at all here. This number should not be changing at all. See, how is he getting closer? This is so weird. Because it's these numbers are saying that he's going from 25 pixels away from us down to only 18 pixels away from us. But he's not moving. So it's like his logic. Distance to player is using the C length here. Okay, let's take out this displacement X here and see if that is fixing this a bit. Because we should be only 25 pixels away. Like he should stop once he's 25. Okay, well, shit. Okay, so I'm curious if we print up his X position, if it will be continuously changing when it should not be. So if we put up the entity's X here, because what's weird is the bat's not moving, but the distance from the bat to the player is variable, so that is just not right. We need to fix that. So this is the X position. Once we should stop just like that. So the X position is fine. And I'm assuming the Y position does the same thing where it just stops once he's 25 pixels away from us. But why is the distance? Yeah, Y is the same. Okay, so the X and Y are fine. It's something in our get distance to player that's messed up. So we take our player X, player Y. Yo, this I don't see how this could be wrong. I mean, I guess we should only run self entity distance to player. I don't know. There's not much to be wrong here. We're just doing the Pythagorean theorem. We're getting the length of our bottom leg of our triangle, the top leg of our triangle, and then we calculate the hypotenuse by square rooting a squared plus b squared. A squared plus b squared. I feel like we're missing something here. Hey Vodka, how's it going? We square the a length, we square the b length, and then, yeah, a squared plus b squared equals c squared, and then we square root c squared to get the length of that hypotenuse, and that's the distance to our player. So we run that function every frame in our process AI, yet when we print up the distance to player, we're getting a variable direction, or variable distance. See, that is so weird. Because we proved our entity x and y position are stable at this point in time. So why would our c length be changed from our get distance to player function? I do not know why. Well, we modify the x, but then we unmodify it after we render. So that means by the time we run this function, we're undisplaced. So that I think that makes sense to me. Get distance to player. Okay, so since c squared is a relation of the a length and b length, yeah, let's stop displacing our position based on displace x, and we'll see if that value goes back to normal, which I'm pretty sure it will. Yeah, if we stop doing this, our distance to player should be stationary again once we get close enough. Oh my god. That's because we're doing this. Okay. Okay, we're looking for a stable number here once he gets 25 pixels away. Yeah. So why is this number changing when we run our function? It's running on... Because here, yeah, we undisplace. Unless... No. I'm trying to think if it's a positive or negative would matter, but since we always add it here, entity displacement x, displacement y, to our entity x. Yeah, we basically say, take our original position and then displace us. And then, okay, you know what? I think we might need this displacement before we check any of the movement stuff. So we calculate we might. And you know what? This stuff might go in the update function. Or let's do it before the get distance to player, because we have to account. Yeah, I think that'll fix it actually. If we do it before that function, we should. Well, let's see. Nice. Are we? We are displacing. Okay. Okay. So why did we not like wiggle left and right? We're not seeing the displace here. Yeah, we're not displacing. Ay, ay, ay. I'm not seeing him wiggle. Yeah, he's not wiggling. And then that's jacked up again. He wiggles. No, he doesn't wiggle. What the heck? Okay, he's wiggling here. So what's the issue here? We're doing this based on distance. And then, so maybe we just let's displace us and then get the distance of the displace. And then we'll render, then we undisplace us here. And then by the time the next frame is happening, we have the distance to player with the displaced value instead of the original value. So this distance should be more accurate because we're doing it based on the displaced distance instead of before the displaced distance. So we're looking for it to wiggle up and down. And we're looking at a solid 25 stop. Yes. And then look, he wiggles left and right, and then solid 25 stop. I mean, give or take a delta time worth. Oh my. Okay, so maybe we up this to 30. Oh my god, that's so close. Oh my god. Yeah, okay. For whatever reason, it feels like when we're on the bottom right of him, he just gets way too close. Oh. God damn. Okay. Let's say this is 30. And then let's see if that looks okay. So we're looking for a 30 stop. He does look wiggling. That looks good. Yeah, 30 stop. He wiggles. Uh-oh. Oh. 30's too far, because look, we might need like 20, 28 or something. Well, that's technically close enough. Yeah, I want him to be a bit closer than that, but let's see how close he gets. Okay, let's do like 28. I don't want him to feel too claustrophobic. I just want him to get close enough to be a threat. So we can touch him there. Oh god. We can touch him there. Okay. Why is this side scarier? Because he's 28 away, but he looks like he's 4 pixels away because he's so wide. Oh, yeah. Because look at the distance here. That's like twice as far. It's because I think it's because he's so wide. You know, he's wider than 16 pixels. So on this side, the distance to the player, the distance to the player is from the top left to the top left. So this is 28 pixels. But the distance from the top left of him to the top left of us here is 28. And look how much closer he is, because we're going from here to here instead of our whole body. So it's almost like we need to calculate distance to player from the right side of our bat if our player is on the left or on the right side of our bat. Oh my god. What am I saying? Yeah. Because the distance to player depends on which side the player is of the bat. So if our X is less than the bat's X, then the distance to player is going to be the right side of our player and the left side of our bat, and whatever that pixel is, right? Not the difference of, not the difference between the top left position of both of our things, but the difference between the space in between us. So like our players plus our width, and then our left side of our bat versus on this side, we need to go to the right side of our bat and the left side of our player. So that's how we need to modify our distance to player. And then we can get more consistent with that distance. But then I'm trying to think of, because then, you know, the same thing goes for here, where if we're above our player, the distance between our player is, and the bat, if we're above our bat, would be the bottom of our player to the top of our bat, versus if we are beneath it, look at how much more space. Wow, look at how bad that is. Because look, that's like a whole sprite, more than a whole sprite worth of distance between us and the bat when we're beneath it, versus when we're above it, it's like just barely one sprite distance. I mean, yeah, there's just so much more gap here. Okay, so I think we need to change this so it's more consistent. So I think what we need to do is find what quadrant we are in relation to the bat, and then we can calculate the distance. Because if we're in the left quadrant like this, then the distance would be from the top right of us to the bottom left of the bat. We can call it that. Then if we're in the bottom right quadrant, it would be the bottom right of our bat to our top left of our player. And then if we're in the top right, it would be the bottom left of us, top right of bat, and the bottom right of us, bottom left of us, top right bat, bottom right of us, top left bat. Gosh. Okay. I think I said that all backwards, but I do like the wiggling he's got now. So I'm going to take off the distance to player here. And let's just look at the wiggle. I think I'm okay with it. Yeah, it looks much better than just the straight line. I like that he looks more wiggly. Especially if we're like directly to the side of him. I think it looks a lot better. Okay. Gosh, why when we collide with the bat should not move. The bat shouldn't get knocked back. We'll have to figure that out. When we get hit by the bat, yeah, we have to figure that out. I'm going to leave a note because it's already midnight, so I'm going to call it. But we'll say that this next episode, we're gonna fix the distance to player so it's more consistent on all quadrants, and then we're gonna get, where is our to-do list? Here. We're gonna do what would we say? Improve distance to player in bat entity, and then also prevent bat entities from moving upon player collision. Because we should get knocked back, the bat shouldn't be touched. Now, I do think once we get touched, we get knocked back by the bat, and that increases the distance to our player. And if our distance to our player is greater than that 25 pixel threshold of distance, then we're going to start updating our bat by the displacement X and Y. And we didn't flush that. We took that out. So if our displacement X was high when the bat got within range of us, then the next frame, once it knocks us out, it could be a jarring movement. So I do think we need to flush our displacement values once we're close enough. But it was looking like it was giving us issues. So we'll try to tackle that tomorrow. And Brightside, thanks for tuning in, man. It's fun seeing you in here. Thanks for hanging, man. Appreciate it. upon nearing player. I'm just gonna call. But yeah, we're gonna commit here, and we'll say that we're gonna commit with a message saying that we added displacement movement for bat entities. And then tomorrow we'll finalize it. So after we get the new and improved bat movement, we'll probably tidy up the sprites a bit, make them look better, and then we'll start adding the attack animation for the bat. So they're going to be spitting at us and attacking us, and then once we get that, then we can build out some dungeon levels where we can get knocked into pits. We have to push boulders off to the side and make a way while we defend ourselves from bats and work our way down to the bottom of the dungeon to get the tunic, the green tunic. So that's what's next. And we're doing pretty good on our roadmap. This is a big step of the roadmap. The dungeon and the bats are the hardest thing left in the roadmap. So once we get that, it'll be smoother sailing towards the demo. But thanks for watching, guys. I'll run the credits here for our supporters. So thanks to everyone who supports the channel. Thanks for all the subs, the likes, the times anyone's here in chat. I really appreciate it. And we'll rate out. Let's see if Hypnotic is doing some dev stuff. He's playing slot machines. Okay. We'll rate out to Salto Manga. He's the great artist who did the artwork for my channel. So the Sekiro art behind as a background here, Salto did. So we'll give him a raid because he's always doing some cool art stuff. But thanks for watching. I'll catch y'all later. I'll be back tomorrow.